Hello, what's up? Welcome back to another video about Earth Science. Now, in the previous video, we were talking about plate tectonics, but we were not able to finish most of that topic. But I explained to you a lot also about the layers of the Earth. So, let's just go through all of those again. We discussed that the inner core is very solid because of the pressure that comes from the weight of the entire Earth pushing down on it due to gravity. And we also discussed that despite the very high temperature of the inner core, about 7,000 to 8,000 degrees Celsius, it is solidified because of this pressure. And the outer core does not have enough pressure for it to become liquid despite it having very, very high temperatures. Okay? Another thing that we also discussed is that the outer core is also one of the many layers of the Earth that are actually protecting us from harmful radiation from the sun, such as its magnetic field. Okay? The magnetic field here, the magnetic field shields us from harmful radiation of the sun. And I also showed to you how Sir Ivan translated that into a picture. How the sun's rays are being deflected by the Earth's magnetic field, protecting us. We are alive! Yay! And then we also discussed that the convection currents in the mantle is due to the difference in temperature. Alright, so let's just zoom in a little bit to this image right here. Over there. Oh yeah. Convection current. I'm just gonna finish this pen over here. Okay. We also discussed that the lower mantle is going to have we also had that correction. The lower mantle is at a temperature of around 4,400 degrees Celsius at the boundary between the outer core, and about 870 degrees Celsius at the top of the mantle. Okay? And then, since there is a major difference in temperature here, there will be a process called convection that is going to happen inside the mantle. Okay? So, this here is the main reason why there is convection current, because of the temperature difference. Okay? Take note of that temperature difference. And then we also discussed that because of the temperature difference, because of the convection currents in the mantle, hot rocks move from the lower mantle to the top, and then cold rocks from the top of the mantle move to the bottom. And because of this, there are two forces that happen. Okay? So, the first force is called as the slab pull over here. Slab pull occurs when there is collision between two tectonic plates. And when two tectonic plates collide, one will sink, and the process of sinking is called as subduction. Okay? Next, the other force is called as ridge push. When two tectonic plates are moving away from each other. Okay? This is caused again by the mantle, by the hot rocks of the mantle pushing up towards the lithosphere. Okay? We also discussed that the lithosphere, is a layer that is composed by the crust and some parts of the upper mantle. And this here is why it's called the lithosphere, because they both move together. And below the lithosphere is a plasticky layer that is very, very fluid, which is going to be called as the asthenosphere. Okay? Again, this here is below the lithosphere, and it is a plastic-like layer. Okay? And again, this is how they move. Convection currents in the mantle influence the asthenosphere, thus moving the crust in the mantle or the lithosphere. Okay? And then also last time we got to discuss about plate tectonics. Let's just quickly go to that. We discussed about plate tectonics, and that plate tectonics is one of the main theories that our outer shell is divided into several plates, such as the tectonic plates, and then they glide over the mantle. Okay, you saw the gliding action a while ago from our illustration, and the plate acts like a rigid and hard shell compared to the Earth's mantle. We also discussed that the Earth's mantle is not liquid but is also solid but fluid. It flows, just like in the very famous image that we have, animation that we have over here. Okay, and also got to show to you the major tectonic plates of the Earth. Now, these tectonic plates are actually moving right now, but sir, at what speed? They are moving at about 2 to 10 centimeters a year. Okay, 2 to 10 centimeters a year. And this movement is actually one of the main reasons why we have earthquakes and why we have volcanoes. Okay, we've discussed that in the previous years in grade 9 and also in grade 8. How volcanoes occur and why how volcanoes are formed, why volcanoes erupt, and why earthquakes happen. It is all explained in this theory over here in plate tectonics. And they move because of the movement of all of these tectonic plates. Okay? We discussed all of that. And a good thing that I would also like everybody to know is that, sir, it's so confusing knowing about the lithosphere, the asthenosphere, the mantle, the core, and the crust. What's the difference between all of these stuff? But all of those concepts are going to be summarized into this illustration right here. Okay, I'm just going to zoom that illustration over there. Now, it's a lot easier to understand if the Earth's layers were classified into two. They are called as the compositional layers. Sir, ano yung compositional layers? Compositional layers, guys, is the layers of the Earth that are going to be composed of the same components. Okay? For example, as what you can see in the image, in the compositional layers na yung nasa left, isa lang yung outer core and inner core. Sir, why? Because both of them are made out of nickel and iron. Okay? So, as a compositional layer, the inner core and outer core are just one. They're both made of nickel and iron. And then we have the mantle, which is mainly composed of silicon and other hot rocks. Okay? And then, as what you have known, the crust is divided into two. The oceanic crust and the continental crust. Those two have different compositions. Okay, because oceanic crust is below the ocean and continental crust is where we live in, where the mountains are, where valleys are. Okay, so for compositional layers, there is going to be four. We have the very thick continental crust, then we also have the oceanic crust, then we have the very entire mantle, and then we have the core, which is the inner and outer core. Now, when we move to mechanical layers, sir, ano yung mechanical layers? Mechanical layers are the layers that move together. As what we have known in plate tectonics, mechanical, all of the layers of the Earth are mechanical. They move. The inner core moves separately from the outer core. Now, nobody knows how the inner core moves, but I think, and I have seen also a lot in my research, that the inner core just vibrates. Okay, because it is solid, it doesn't move anywhere. It just vibrates in its place. Okay, ganun lang. And we also know that the outer core actually moves. When the outer core moves, it produces a magnetic field. A moving charge produces a magnetic field. Okay, so that's why the inner core and outer core is separated for mechanical layers. They move differently. Now the mesosphere, we can just name that as the mantle, because the mesosphere is the mover of those convection currents. The difference in temperature is also there. Now, this is where we put into the asthenosphere and lithosphere. So, as what quick correction, as what you've known, the asthenosphere there is spelled differently. That's totally fine. Asthenosphere, AE, or asthenosphere with an A lang. It's just totally fine for spelling. The asthenosphere moves independently from the mesosphere or the mantle and the lithosphere, because the asthenosphere has a plastic-like layer. And we also discussed that the lithosphere is composed of the crust and some parts of the upper mantle. Okay? So it's a lot easier to understand like that. We have compositional layers, the continental crust, oceanic crust, mantle, and the core, because they are made out of the same components. They are separated by that way. And we also have mechanical layers. These are the layers that move together. The crust and some part of the upper mantle, they move together, so they are called as the lithosphere. Then you have the asthenosphere, which is a plastic-like layer that moves independently too. And the movement of the asthenosphere is influenced mainly by the movement of the mantle. I'm just calling the mesosphere as a mantle, because we are going to use mantle in our discussions, not mesosphere. The mantle is where the convection currents are moving. Outer core moves independently and produces that magnetic charge. Okay? Now, when we talk about these forces because of the convection currents, these two are, this layer is gonna be the lithosphere. Okay? The tectonic plates are the lithosphere. This plate, lithosphere. Okay? The tectonic plates, they are not just the crust. Kulang, not enough. The tectonic plates are the lithosphere. Okay? I'll see you all in the next video. We have been, for this video, we took a review of what we had in the previous video. We talked about the layers of the Earth's magnetic field, and then how the asthenosphere is also influencing. We also mainly discussed a very important point about the compositional and the mechanical layers of the Earth, and we came up with the conclusion that compositional layers are the layers that have the same composition. For the core, iron, nickel; for mantle, silicon and other rocks; the continental crust and the oceanic crust; and then the mechanical layers are the layers that move together. Okay? See you in the next video.